Buongiorno a tutti, benvenuti al capitolo 3. Welcome to everyone to our chapter 3 about firms in the marketplace. And when you look around, I'm sitting in the middle between firms in the marketplace, targets of firms, profit maximization, up to production and production function. So there's quite a lot to cover in this chapter 3, and I'm happy to be doing this together with you. Chapter 3, first video, and this first video covers the first 3 parts, 3.1 through 3.3. 2 short introduction, the business problem, definition of short run versus long run, which is an important definition and that we should keep in mind. And then the big part, chapter 3.3 or part 3.3, the nature of productivity and costs in the short run. This will be several steps that we do, and it's important to keep in mind what are the steps, what is it that we are going to do and that what we want to do. We start, when we think about firms, about the target. What is it, or the goal? What is it that firms want to achieve? And typically we assume that it's about profit, it's about maximizing profit. As we already said, there are other potential targets, but the most important one is maximizing profit. We are going to question this a bit later, but let's follow this at the moment. And the typical definition, profit is revenue minus costs. So profit, typically abbreviated with a pi, a capital Greek P, equals total revenue minus total costs. We're going to hear a bit more about what this total is and why we say total. In order to do this, to be able to calculate total revenue minus total cost, we first of all have to define, okay, what is that? And you see that we start the other way around. We start with costs and the cost function in the second step. And in order to understand, to be able to talk about costs and cost functions, we need the first step to talk about production functions. So that's the first step, 2 steps, you could say, that we do in this chapter 3. Production and then the cost derived from this production in the different functions. In order to be able to talk about profit maximization, we have to clarify a bit more about revenue. How do revenue functions look like? And this we are going to do in chapter 5, surprisingly, but the chapter 4 that is in between talks about markets, brings together supply and demand. As this is what our chapter is about, firms in the marketplace, background to supply. So as we derive the demand function in chapter 2, we're going to derive the supply function here in this chapter 3. Okay, we said we typically start with production. Before we do so, let's refer to our presentation. As you know, the presentation is available and gives you an overview over the book, tells you the table of contents that we already looked at. We are going to learn the supply function, the determinants of supply, and then most important, not most importantly, but that's the first step, to talk about production, the production function. And again, another law, the law of diminishing returns in this case, economies of scale, and so on. These are some of the topics, the difference between the short and the long run, difference between variable, fixed, and total costs, and different concepts, not only the total, but also the average and the marginal costs, product, and later on profit will be something that we refer to. Also, this slide that we already had a look at, you find in our presentation, of course. 3.1 is relatively short. It just says managing cost and makes the difference between fixed costs and variable costs. And I suppose most of you are aware of this. Fixed costs are constant. They remain the same whatever the level of output, whereas variable costs vary with the output. When I produce more, I'm going to have more variable costs. How do we manage this? Another definition, which is already 3.2, is about the short and the long run. This is something that is going to reappear several times throughout the chapter. In the short run, only one factor of production is variable. In the long run, all factors of production are variable. And that can be our first step, thinking about factors of production. And that's something we discussed around 2 weeks ago. What are the factors of production? We talked about labor, land, capital as the typical three, and then said we add enterprise or entrepreneurship, the people who start firms, who start enterprise with visions, new things that they are convinced will be successful on the market. So these are the production factors. And from here, let us go to the production process. Also for this production process, the slide, I already copied the slide here to our whiteboard. And you can see here the production factors, labor, nature or land, capital, and entrepreneurship. I even didn't write this down here, but we know that's the fourth one. And these production factors in the production process are converted to goods and services, which can be cars, bread, shoes, haircuts, milk, holidays, education, and so on. So at the end, all these production factors are transferred. You could say they all, you see the arrows here, they all go in there. There's something happening to them, and then they are transformed to the different goods that we want. And this in between that I made like this with some circles is called a production function. The transfer of the input factors X to output Q. And when we look at this, the graph in this case is sort of also mathematically the usual way around. We could say we put the X as the independent variable on the horizontal axis and the dependent variable Q as a function of X on the vertical axis. And now our question is, okay, how might this look like? We can have a bit more discussion later on in class. I suppose we would agree that basically that's something like an upward sloping line. But is it sort of linear as I did here? Is it progressive? The more input factors I put into this, the even higher the marginal product, or might it even look like this? And in fact, a production function that basically looks like this, where the marginal effect of one more X, of one more input, becomes a bit smaller, at least at the end. That's a more typical production function. So this one could be a production function that we see in some books. We are going to deal with one that is a bit more sophisticated, saying when we start, there will be an increase, but then there's a turning point and even a maximum might be there. And we call this our production function, our total product. And by the way, often we look at one production factor here. And you might recall that we said short run means there's only one variable factor and the other factors are fixed. So it's again something like ceteris paribus, as we have been discussing before. So typically what we look at is X1 is labor. And so we could say 1 worker, 2 workers, 3 or employees, 4, 5, and so on. And the more workers, the more employees we employ, the higher, first of all, the output, and then this increase in output goes down. This is something what we call the diminishing returns to scale. So that's one argument here. Another thing that we already find here is our objective, or the objective of firms, that we assume maximizing profit, and that this maximized profit is found at the point where total revenue minus total cost is at its maximum. And then from here, we are going to derive later in chapter 5 that this is the point where, in fact, marginal revenue is equal to marginal cost. but that's something we don't have to discuss intensively here. Let us go ahead and look at this production process, our production process or production function, using an example. Our book gives us table 3.1 and the figures 3.2 and 3.3 that show basically the graph that we have been looking at. But what I'd like us to look at, because I find this a nice example, is something that students, in fact, produced some years ago by talking about this chapter and then say, let's take the example of the Pizzeria L'Armonia. Computer ignored again, so this is how it should look like. The Pizzeria L'Armonia, where they look at the question, how can we find the point of maximum profit and which factors are thereby involved. And let's do this. Let's look at a production process of pizza. Now, that's why we started this session a bit in Italian. Production process of pizza. We see here several elements. We see the kitchen of a pizzeria. We see also the restaurant there. This is obviously the door to the restaurant. We have the oven and the rest of the kitchen where production can take place. But the input factor is labor. The other inputs are held constant. These are the other inputs. Labor, land, so the area and the restaurant and so on. And capital. And you might recall, capital is not about money, but capital is about the things that we use in order to produce something. So the ovens, the stoves here, the machines, and especially the oven are the capital, and this is fixed. So as long as nobody works there, we are here at the point 0, 0. No employees, no pizza. Let's say now we employ someone. Let me introduce you to Francesco. He is the first person working here. As long as Francesco is alone in the restaurant, in the pizzeria, he might be able, you can see this here, to produce one person, and then over there, that might be 3 pizza. Because having only one employee is something that doesn't work well. So if we enter the pizzeria, we come into there, we sit down, we wait for Francesco. Francesco comes, he takes our orders, writes them down, brings us the drinks, writes down the order of pizza, goes into the kitchen, starts decorating the pizza, putting the pizza in the oven, and so on. A quite sort of, you could say, inefficient thing, and he might be able to sell 3 pizza in an hour. So we need more. Let's employ Alessandro. Having 2 people here, they can divide their labor. They can say, okay, Alessandro is the one who is in the restaurant, who takes the orders and so on, and who serves the drinks, whilst Francesco is able to here, okay, 2 pizza, 4 stazione and 1 pizza frutti di mare or whatever. And then he can do this and produce, and the 2 of them together are able to produce 10 pizza. 2 labor, 10 pizza. This is what you can see here. 3 people, meet Leonardo, have, you could say, sort of not the highest output, but the highest output per person, which we are going to look at. We could say the second one, Alessandro, he increased the production from 3 to 10, so by 7. The third one, Leonardo, he increased the production from 10 to 24. And so this increase is the highest. And now let's say we hire further. We hire Lorenzo, we hire Mattia, we hire Andrea. And then you can see that the extra output becomes smaller. That's why here we have this B. Up to here we had increasing returns to scale, increasing returns to scale. And from there on, there are decreasing or diminishing from B on to the right. It might even be that after these 6 people are employed, we come to point C, and that might be the maximum output. And if you have a look at this crowded kitchen here, you might as well have an idea, because people here might be even in their way, and it's not possible to produce more. And if we hire even more, so we hire Gabriele, Ricardo, now we have 8 people, we have 8 people working here, some in the restaurant, but most of them in the kitchen. Still, the production of pizza not only is not increased further on, but it might as well go down. And what is the reason? The reason is that all the people here are in each other's way because of the restriction that we said in the short run. Only one factor of production is variable, and that's the factor labor. The other factors, land, the space that they have here, is not variable. And especially capital, the stove, the machines that they need, and most importantly for pizza, the oven, is limited. It doesn't change in the short run. And that's why we come typically to that development that the output not at least doesn't increase, but it might as well go down. Okay, so let's have a look here, or the pictures that we have in our book. From this total product in this direction, we now are going to look at number 1, the marginal product, the individual increase when one more worker is hired. That has a maximum here at B. This is what we saw. And after this not only goes down, but might become negative after point C, after the maximum. And we are going to look as well as at the average product. Okay, so that was quite some information, and let's discuss this information more intensively here in our board. And let's write this down. So I copy that graph into our board, and we could say, okay, what happens in our pizza L'Armonia? How can we observe this output? Production function in the Pizzeria L'Armonia. Our production function, or total product, is marked in red, and we can see the numbers. When the amount of labor is 0, 1, 2, 3, up to 8, L starts with 0, 1, 2, 3, 8. Then our output, total product, is also 0, is 3, is 10, is 24, 36, 40, 42, and then it goes down again, 41, 40. This is what we see at the total, or as the total product. Now, what about these changes? MP, marginal product. We already heard a bit of marginal when we discussed Menkhu's principles. People think at the margin, and we define the margin sort of as the extra outcome. The outcome if I add something extra. So here it's the additional output, additional amount of pizza, if I employ one more employee, if L increases by 1. We can also define marginal product as the change in output over the change in input. In this case, delta total product divided by delta L input of labor. And it's just the difference here. From 0 to 3, there is a change of 3. From 3 to 10, there's a change of 7, 14, 12, 4, 2, and then we come to -1, and in fact we have twice -1. That's the shape of marginal product, and we can show this in the graph. We can show the 3 here between the 0 and the 1, and then we start at a level of 3, we go up there, we can see the 7, and when the third worker, when Leonardo comes, then we start at a level of 3 and go up to, at the level of 10, I'm sorry, here there's 10, and go up to 24, which is 14, and so on. Let me quickly add the others. These are sort of the step function shows the marginal changes. we can also draw this marginal function, because here for the first the value is 3, for the second the value is 7, for the third the value is 14, and so on. Putting the points in and then connecting the dots brings us the marginal product. Never claimed that my drawing is nice, but you can see the message. We have the maximum here at the 14 before it goes up and then it goes down. That's what marginal product does. And when we look at this second part here of the marginal product, that is where the additional production, the marginal product, goes down, and that's where we talk about MP. And is in the second part where MP goes down, we talk about this diminishing returns to scale. And in this downward sloping part of the marginal product, we talk about diminishing returns, or the law of diminishing returns. Returns of employing one more employee. The third concept that we are going to talk about is the average product. And we all know what an average is. It's the sum of sort of what comes out of it divided by the number of people. So AP is total product over the quantity, the number of workers, L. So we can compute this. 0 over 0 doesn't make sense. 3 over 1 gives me a 3. 10 over 2 gives me a 5. 8, 9, 40 over 5 gives me an 8 again. 42 over 6 is again a 7. 41 over 7 is something like 5.9. And then we are back at 40 over 8, which is 5. So we see that also the AP is a function that first increases, then decreases. So this is something that looks a bit similar to the MP, but it can't be negative. This term here, total product over whatever, these are both positive numbers that can never be negative. And we can draw our function with the maximum at 4. That will be our maximum. At 4, it has a maximum of 8. And then our function starts and goes down again, goes first up and then down again. One thing we might note here, and we are going to see this later on here, it's just sort of a hint, that the AP is intersected by MP in its maximum. We can put this in brackets here at the moment, where we do not directly refer to this, but later on when we talk about the different cost functions, we will see that this is quite relevant, and it helps us understanding costs and the decisions of firm whether to produce and how much to produce. Okay, so that took some time, is our analysis of the production part, the production function. And the next step is to think about costs. This is what we saw here. First of all, understand the production function, and then from this derive the cost functions. And deriving means, okay, let us think about this graph and how can we make from this production function, how can we come to a cost function? When we think about this graph here, we have total product, the number of pizza, and the number of employees, but there's sort of no money in here. How can we enter monetary terms? Because if we want to deal with costs, we have to say, okay, what does it cost? In pound, in euro, in dollar, whatever. A moment where you could pause your video for 10 seconds, 20 seconds, whatever, and think about it. Where in this graph we have been talking about, is the hint to a cost function? Where could we say, okay, this refers to a monetary equivalent? So, end of pause. I suppose most of you came to the fact that, okay, employing people costs us money. If I employ one person, 2 people, 3 people, this is going to be my cost, depending on the hourly wage. Let's say the people earn $15 per hour. Then my hourly costs are still 0 if I do not employ anyone, but they are 15 if I employ one person. They are 30 if I hire 3, 45, 60, 75, 90, and so on, 105, are the costs. So this, we could say, is we transferred this axis into a cost function or a cost axis, which here might be costs to employ workers. Transferring this function basically means exchanging the axes, because now we put the quantity as the independent variable and the cost as the dependent variable. So the quantity goes sort of down to the horizontal axis and the costs go to the vertical axis. So we have quantity down here and we have costs, different concepts of costs, such as make a C, at this axis. And what happens if you turn around a figure, you basically mirror it, the graph that we see there is a graph that also turns around. So when we had this shape before, the shape now will be the other way around. These are our total variable costs. And it directly comes, that's why the lower diagram is below the upper diagram. It directly comes from, as I said, changing the axes here, and then the graph turns and looks like this. That is our cost function, the total variable costs, because it's the costs of employing 1 to 3 workers. This cost function refers to the quantity, so it's no longer about how many workers I employ, but how many pizza I make. What is my total output, my quantity Q? Okay, variable cost, because it measures only the costs of hiring more or less people. We already had in the presentation the definition, the distinction between variable costs and fixed costs, which together make the total costs. Let's briefly go back to our presentation. The next slide is, in fact, costs in the short run. Variable costs vary with the level of output. Fixed costs are constant. So total costs are fixed costs plus variable cost. Fixed costs are constant for all level of output, which means that my fixed costs are typically a horizontal line. And my total costs now are total variable costs plus total fixed costs. Or the other way around, normally we start with total fixed costs, which means we start here at a production of 0, the costs are the fixed costs. And from there on, I have to add the total variable costs. So my total cost function looks like this, because it's always adding up. It's sort of a parallel distance here between average fixed costs and average variable costs. I hope it became clear why we did all this, why we started with this production process, deriving the production function here a bit more intensively, in order to be able to say, okay, if this is the production function, then we get this shape of cost functions. And you have some numbers here. These are the total costs. And that's why we continue here with total costs. And if you look at our graph, our book, or in the presentation, you will see that there is this difference between the total costs that we have in figure 3.4 and the costs per unit, the different concepts of costs per unit in the lower graph in figure 3.5. So let's make clear, the upper graph is about total costs. And this total cost does not only refer to TC, which are the added total cost, but also total variable cost. Total fixed costs is not the cost per unit, but it's added up. If I'm here at 100 units, then my costs are this. If I'm at 200 units, they are here, and so on. And we distinguish from this the costs per unit. And these costs per unit are also defined in our book and on the slide. I copied this from the slide. Short run average and marginal cost. You can see everything here, short run average total cost, short run average variable costs, and so on. And at the end, the short run marginal costs. And we already know in the meantime the definition of margin. If I increase the production by one, if I produce one more unit, one more pizza, what is the additional cost? And you can see here in figure 3.5, put this closer to each other, you can see here in figure 3.5 how these all interact and sort of where that comes from. I'd like to sketch this briefly, but it might at the end be better to refer to these two figures as they can draw definitely better than I can and I do. Just highlighting a bit the relation between those two, between these upper total graphs and the graphs per unit, has to do again with the turning points, with the points where the total revenue, total cost function here, first of all, turns around as it goes from sort of going down over proportionally to going down under proportionally, and then the turning point here where it starts to increase. Deriving these four types, we can start with the total fixed cost. Fixed cost means, as we heard, when we produce more, the fixed cost, here, the fixed cost doesn't change. What does that mean for the fixed costs per unit that we are looking at here? It means that per unit it goes down, that the fixed cost, average total fixed cost basically looks like this and becomes less. It's not down at the axis, but very close to it. Talking about the marginal costs, we see that basically the cost function here goes down. This going down means that the next unit is cheaper than the unit before, up to that turning point, and then after the turning point, each next unit is more expensive than the unit before. And this is what shows itself in how the marginal cost curve looks like. It has a minimum, in fact, here, and before this point it goes down, and then after the point it goes up. This fact that the short-run marginal costs have their minimum here is hopefully clear to see. If not, of course, we have the possibility in class to discuss your questions. So let me remove the upper part as it disturbs the graph over there. The last thing that we look at is the average cost, the short run and the long run average cost. And in fact, we see that the average cost, we can also see this here, goes down only briefly, then has the minimum, and then goes up again. And in fact, the point where the average cost has its minimum is this point, where there is another turning point at the total cost. So average costs have their minimum on this dashed line, and in fact they have their minimum at the point where they intersect the marginal costs. Short run average total costs, horrible abbreviations, but I can't change it at the moment, are like this. And as I said, you can see it better here, but I wanted to derive it with the relation to the upper graph. And again, and here even more importantly, we can and we should keep in mind that the average costs are intersected by the marginal cost in their minimum. Something we are going to have a closer look at on following slides, but let's keep it in mind for the moment. With this finding, we end our first video, the first part where we heard it's about the derivation of costs in the short run. You see, the next step is to talk about output decisions in the short run and cost efficiency, and then enlarge our analysis to long run. That's the next video. Thanks for watching this. See you later.